So we can look at some solving equations. Now you should be familiar with the work that you've done on how to solve fairly simple equations like the ones here. So, and you'll be using the sort of laws of algebra, or even inspecting the equations. So 28 equals 7 times x. So you'll know from your 7 times tables that the answer will be 4. You could do it by moving the 7 across to the left-hand side. If it's multiplying on one side, it divides on the other, and that would give us x equals 4. You can always check 7 fours makes 28. Come to the next one, we've got 15 subtract x equals 10. You should know that the answer would be 5 because 15 take 5 is 10. Again, algebraically, we could write 15 equals 10 plus x, and minus x goes to the other side of the equation and becomes a plus. Again, you should see that it's 5, or you can do 15 take 10 equals x, and x equals 5. Now the techniques are good if you have difficult numbers, things with decimal points and so on, but with whole numbers you could have right away seen the answer was 5. And finally, if x divided by 5 is 8, and undo divide by 5, we multiply the 8 by the 5, moving it to the other side, and it becomes the opposite of what it was doing. So it was dividing, it now multiplies. That gives us x equals 40, and we check that 40 divided by 5 is 8. Now we're looking at a different type of equation here. We've got x on both sides of the equation. So what I can do, and I'll do it slowly to start with, is I'll move my x from the right hand side to the left. Now you might say to me, well, why didn't you move the 3x to the other side? Well, if you move the smaller number of x's, then you won't end up with negative values. So I'm going to move the 3x, so the x to the other side. I'm going to write it. I can write it where I like. I'm going to write it next to the x. I'll leave the 5 where it is, and I'll write equals 22 now. So my x goes across to the other side and becomes minus x. So 3x subtract x is 2x. So 2x minus 5 equals 22. Now the 5 can be moved to the other side, and we have 2x equals 22. It will do the opposite thing on the other side. It will become plus 5. So we've got 2x equals 22 plus 5, which is 27. And so x will equal half of 27, which is 13.5. Now, I'll show you a faster way of doing that. I could have moved my x's to one side and my numbers to the other in one go. So I could have said it was 3x minus x equals 22 plus 5. Okay, that takes me misses out a step really. Then I do both steps, 2x equals 27, and then I can write x equals, I should know it's 27 divided by 2, and write 13.5. So you don't have to write lots and lots of steps, just doing them so you can see exactly what's going on. So we'll do one more here then. Let's suppose we had 2x minus 8 equaled, say 6x plus 22. So I'll move my x's. Now I want to move my 2x across because the 6x is the larger of the two, and that will mean I will keep a positive x. I want to move my 22 to this side, so it doesn't matter where I write it, I'm going to write it as minus 22, and the minus 8 didn't go anywhere, so it stays exactly where it is. So to recap then, we move the 2x across, and it becomes a minus 2x, and we move the plus 22 to the other side and it becomes minus 22. Now minus 22 minus 8 is minus 30. 6x takes 2x is 4x. Could, if I wanted to write that like that, exactly the same statement, just written the other way around. So 4x equals minus 30, x will equal minus 30 divided by 4, which is minus 15 divided by 2, which is minus 7.5. So there's two examples of solving equations where the variable x is written on both sides of the equation.